Hello everyone, my name is Abraham Wolcott. I'm an assistant professor. I work in the Department of Chemistry at San Jose State University, and I am a physical chemist. For the STEMnet presentation, I will be talking about diamond surface chemistry, synchrotron radiation, and the TES detector. I'd like to acknowledge before I move forward the hard work and dedication of many of the lab members in the Surface Science Center lab at San Jose State, many of which have gone on to careers in chemistry, engineering, biology, in PhD programs, as well as being recognized with federal funding across the United States. During this talk, I will also cover our support by the Department of Defense for our work on nanoscale diamond and get into some of the fun tools that we use in our journey to look at the atomic and molecular structure of diamond itself. In this particular slide is a resonant inelastic X-ray scattering map, and this is giving us a full picture of the electronic structure of nitrogen moieties on the surface of diamond. And what you can see is that we've got both a absorbance and emission spectra giving us information about the unoccupied and occupied density of states. And this is collected with the transition edge sensor, a quantum superconducting device that's housed at the Stanford Synchrotron radiation light source. The TES detector is very special. It's held at 60 millikelvin and basically is one of the world's most sensitive thermometers, and you can see it over there in the picture. It's housed at the beamline. And basically what happens is that X-rays collide with the TES detector, slowly raising its temperature, and when its temperature is raised, the resistance slightly changes and increases from being superconducting to non-superconducting, and then we read out the current that's being generated, and then we can back calculate out the X-rays that strike the detector. Why is this so interesting? Well, we really want to know about the atomic and molecular structure and how this is occurring once electrons go from their ground state to their excited state and back down again. So I'll give you some details about physics and how a synchrotron works and the type of experiments that we're conducting there. The whole process is really focused on diamond because diamond hosts the nitrogen vacancy center, a room temperature magnetic and electric field sensing device, which is fluorescent. So as you can imagine, the capabilities would include tracking of a biological process in real time, maybe even watching neurons fire in real time, and being able to do things like magnetic resonant imaging in room temperature settings. And the NV center is a quantum bit and is described precisely by quantum mechanics. So I really look forward to seeing everybody in May, and thank you very much for your time. Thank you so much. Bye-bye.
Hi, my name is Scott Hauswirth. I'm an assistant professor at Cal State Northridge in the Department of Geological Sciences, currently in my 5th year. My research focuses on hydrogeology and specifically water quality. I'm excited to share a project that's really a collaboration among several faculty in the department. It's really interdisciplinary, and essentially we're creating an analytical center that will let us do all sorts of cool things, ranging from environmental science and water quality to sort of traditional geology style work, to applied geophysics to paleoclimate, really the whole range of things we do in this department. So excited to share that, as well as some of the research we plan to do with the equipment, and also to connect with others in the CSU with similar research interests. Thanks.
Hello, I am Dr. Daniel Fernandez, and I am a professor at California State University, Monterey Bay in the Department of Applied Environmental Science. I have been a professor at CSULB for the past 25 years, and I am excited to be part of this webcast because I think it represents, this funding opportunity represented for me a huge step forward in terms of spreading and disseminating my research and being able to do my research in an even more comprehensive way than I had been able to before. And I'm hoping that as attendees, you'll hear from me in terms of what worked for me and why I think maybe this proposal was funded, in the hopes that perhaps your work could also be funded by this grant opportunity. And also how I think that my research, the emphasis on regional application, actually strengthened my chances of getting the proposal, and it all kind of turned out well because of the COVID lockdown, in the sense that regional research was really all I could do. And fortunately, this grant supported that. Something interesting about myself that I'd like to share with you, a little fun fact, is that for the past 5 years, until the COVID lockdown anyway, I was training Brazilian Jiu-Jitsu. I started at the age of 49, and in this video here you see me actually rolling with my son. He's the person who encouraged me to take it up. And it's been a great experience, and Brazilian Jiu-Jitsu is a lot like wrestling, except instead of trying to pin the other person, you're trying to submit them, to get them in a position where they really can't escape and would face body damage if it went any further. And then they're supposed to tap you when they reach that point, in which case you kind of won that one. But just the idea of training it has been quite an experience for me, especially at this age. Thank you. I look forward to seeing you and perhaps having you see me at the event coming up. Bye-bye.
Hi, my name is Dr. A.K.M. Newaz, and I'm in the physics department at San Francisco State University. I'm currently an associate professor. I'm here in this university almost 7 years now. So I'm very excited for this webcast because I think I'll be able to make connection with other CSU peers that may help my research and other scholarship activities. So fun facts I can think about, well, when I'm not working in the lab or not teaching, I like to bike with my kids or go for small hikes in the Bay Area. So again, I look forward to seeing you all in the webcast. Thank you.